You would have experienced a situation in which the electricity goes and comes back after a few seconds, then again it goes and then again it comes back after a few seconds, then goes and then comes back after a few seconds. This is because there is a fault in the distribution network and the automatic circuit reclosers are working. In this video, we are going to understand what is this recloser and why do we need it, what is its function. So to get that details, you need to watch the video. So reclosers undoubtedly is one of the most important equipment in the distribution network. So let us talk on that in this video. So almost 80 to 90% faults that happens in the distribution network are transient in nature. What do I mean by that? I mean that the 80 to 90% fault that happens in the distribution network are temporary in nature, which means it will remain in the system for a very short time and then it will vanish automatically. You don't need to do any manual intervention for that. It will vanish automatically. Let us understand that more with an example. Let us say I have a company named TheElectricalGuy Power Distribution Company, wherein I'm delivering power to different consumers. Here I have two feeders, feeder 1 and feeder 2. By the way, if you want to learn what is feeder, what is distributor and what is service main, I have a dedicated video on that. I'll provide link for that video down in the description. You can go and check it out after this video. So we have two feeders, 1 and 2, that is connected to residential load, hospital and also the commercial buildings that we have. And the red switch symbols that you see here represents the circuit breakers that I have installed here. Now imagine a very high speed wind is blowing and as a result two of my conductors stick together. So what will happen is the system will detect its abnormal situation and this circuit breaker will open here. So my residential load is not getting power anymore, right? Now, in order to clear this fault, what I have to do as a company, I have to send my engineers to the site, see what has happened, and then close the circuit breaker manually. And then the power will come back to this residential zone. In this process, I've lost, of course, time, cost, because I have to send people there and a lot of things. So this is just one example of temporary fault. High speed wind is blowing and the conductors are getting attached. There are other reasons as well. Like the second reason why a temporary fault can occur is because of the lightning stroke. Let's say there is a lightning stroke. My circuit breaker sensed it's an abnormal situation. It opened, but after a few seconds, the lightning stroke has gone. Now the system voltage is at normal, but still again I have to send somebody check and manually close the breaker to restore the power supply. Again I'm losing money and time here. Or maybe let's say there are some animals, birds, who bridge the gap between the two conductors and as a result there is a fault. Circuit breaker opened but that fault vanished once the animal went off. Or maybe there is a tree branch falling on the lines and then there is a fault. Or maybe there is a switching surge for very few milliseconds or something like that. All these are the examples of the temporary reasons for temporary faults. And in all these faults, my fault is getting vanished automatically. But still, I need to send somebody, I need to clear that fault, manually close the circuit breaker manually and then restore the power supply. And this whole process, I'm losing money, I'm losing time. This is a problem for me. My customers are not happy, right? So what is the solution? Now, when I know that 90% fault that happens in my system are basically temporary in nature, that will vanish automatically after a few seconds or milliseconds. So can I automate this reclosing of the circuit breaker? Simple question. The answer is yes, it can be done. We can automate the reclosing of the circuit breaker, and that device is what we call as automatic circuit recloser. So what you can see on your screen is the image of the recloser. In a simple term, what is this device? This is basically a circuit breaker which has capabilities to sense the abnormal condition and open when needed and reclose when needed, right? In a simple language, this is the device, how it looks. Now, if we look at the proper definition of recloser given by IEC 62271-111, it says that it is a self-controlled device for making, carrying and automatically interrupting and reclosing an alternating current circuit with a predetermined sequence of opening and reclosing, followed by resetting, hold closed or lockout operation. So basically it is a self-controlled device which is capable of making, that means closing, carrying continuously and automatically interrupting normal as well as the fault current, right? And of course there is a sequence on that sequence it operates, and after that sequence, if the fault is not clear, then it should go into a lockout situation, or it should be open permanently, and then of course you need to do it manually. You need to manually close that recloser, right? So that is the proper definition given by the IEC standard. Now let us see what a recloser consists of. Now we have seen by the definition it performs the functions like opening during the fault condition, sensing the fault condition, and also reclosing, right? So first of all, this device must have a circuit breaker, right? That is the basic need to open and close the circuit. So here you can see this is the insulator in which there will be an interrupter which interrupts the fault current and also the normal system current. So this is for R phase, Y phase and B phase. And of course, to operate this interrupter, there will be a mechanism, and they use a vacuum or oil or SF6 for interruption purpose. Plus, now circuit breaker, are they capable of sensing the abnormal condition on their own? The answer is no. We need some devices which will sense the abnormal condition in the circuit, right? And for that, there will be a protection relay which will sense the abnormalities in the system. Again, the question is whether relay that we will be using capable of taking the input of high voltage that we will be using like 12 kV or 24 kV, or maybe the high current like 1000 ampere, 800 ampere. The answer is no. We first need to lower down the values of voltage and current, and for that it will also have current transformer and voltage transformer which will lower the values so that we can give inputs to the relay, and then relay will give inputs to the circuit breaker. So everything put together is what is our automatic circuit recloser, right? Understood? A very useful device. Now this device you might not see very frequently here in India, but it is very widely used in the different countries. And also the advantage of this device is that it can be mounted directly on the distribution pole. So here you can see the image. It is mounted directly on the distribution pole, and to that same pole there is a box connected which is a control box. Basically it will have all the relays, all the control circuitries, and everything will be connected. From here it will get input to open and close like that, right? So that is automatic circuit recloser. Now the point to note here is that they are used only in distribution network. You will not find this in high and extra high voltage transmission lines, and they are available up to 38 kV. The IEC standard for which we have already talked, it's IEC 62271-111. That is the IEC standard for automatic circuit recloser. The current rating depends. It can go from 630 amperes to 1200 amperes, normal rated current. Now how the recloser operate, what is the sequence of operation? Let us talk about that. Now this is the sequence given again by the IEC standard. So what will happen is, let's say I have a recloser installed on a pole, and there is a abnormal condition which is sensed by my recloser. The moment it senses, it will open. So this O represents open operation, right? It will open. Then this T represent a particular amount of time. So it will wait for some time. So this time is around 0.5 seconds. So it will wait for 0.5 seconds. Then it will reclose again automatically. Now if at this moment, if the fault is cleared, it will remain in the closed condition. But if the fault is still there in the system, it will immediately open. So C represents the close operation, O represents the open operation. Then once it is open, now this time it will again wait, but it will wait for a little longer time. And this time is generally 2 seconds. After 2 seconds, it will close again automatically. And if the fault is cleared, it will remain in the closed condition. But if fault is still there in the system, it will open again. The moment it opens, it will again wait for some time. Now this time again, it will wait for some more time. Now this time is generally 5 seconds. After 5 seconds, it will close again. If fault is clear, it will remain closed. But if not, then it will open again. Now this time the recloser will consider this as a permanent fault and it will remain open. So now this time you have to go manually and close it. You have to go and manually close the recloser in order to continue the supply, right? And this gives me a lot of advantage because I don't need to go every time fault occurs and to check whether it's a permanent fault or temporary fault. This recloser will take care of that. If it is opened and it remains open for a long time, that means the fault is permanent and I need manual intervention, right? Clear? So that is what we call as the operating sequence, which is given by the IEC standard. Now this recloser comes in multiple options. You can see a 3-phase recloser like this. So it will have 3 different interrupters, which is ganged together. This is also called as mechanically gang operation. That means if, let's say, even fault happens on only a single phase, all the three phases will trip and reclose accordingly. There is one more option, which is a single phase reclosure. Now this is only a single phase item, means only single phase will be operated. Now this is generally used where taps are taken from a three phase feeder. Right? If only single feeder is going, single distributor is going, then the a single phase recloser will be used there. Or there is third option, which is three single phase reclosers, which means that every phase will have its own dedicated mechanism and they are capable of performing single phase reclosing and also three phase reclosing at the same time. So those are the different options available. And as I mentioned, they comes in oil option, so oil for interruption and insulation medium, or vacuum for interruption and insulation medium. Now the advantage, what is the advantage for my company if I use this recloser? For example, I replaced all my circuit breaker with the help of recloser. Now very heavy wind is blowing, two conductors are connected together, the system will sense it, recloser will open. But after some time, when the wind is again to the normal condition, in few seconds the conductors will be separated and the fault is automatically clear. The recloser will do its sequence, and when it senses that fault is now no more in the system, it will remain in the closed condition and my supply continuity is back without any manual interruption. I need not to send any engineer there to check. I need not to send any person to manually close the breaker. It is closed automatically. The supply continuity is maintained. My customers are happy. My company is happy because I'm giving a continuous supply to my customers. So everybody is happy. And that is the function, that is the importance of recloser in the distribution network. Definitely, you will not see it here in India, very frequently used, but in other countries it is used very, very widely, right? So that is about the automatic reclosure. I hope you have got a basic idea about what is this device and what is the function of this device. If you found this video helpful, then do comment helpful in the comment section. In that way, I'll understand this type of content is helping you. And if you find my YouTube videos helpful, then you will also love the different courses I've created on electrical engineering and on switchgear. You can go and visit courses.theelectricalguy.in for more details. I'll provide a link for that down in the description. Thank you so much for watching, guys. I'll see you in my next one. But till then, keep watching, keep learning.